Hello, my name is Robert Behrens. This is Fluent project number 3 for Dr. Osbay's Fluids class of spring 2023. We're doing the flow around a cylinder for this project in 5 different cases with five different Reynolds numbers. So we're in Workbench right now. As always, gonna drag our fluent out. I'm just gonna name this A because we have 5 different ones, so keep track a little bit. So I'm gonna make this, or I'm gonna go to new design model or geometry to make our geometry course, like usual. All right, get our axis set up. I'm not gonna change my units. I'm gonna leave it in meters. So I want circle. I don't think I grabbed the origin. So circle. There we go. So I already calculated my Reynolds numbers. So that's why I'm doing meters. I'm just gonna do my diameter here. I used 5 meters for my diameter of this. And then we'll draw a rectangle around here. Want to have that longer tail so we can see what happens after the fluid hits our cylinder. And this part isn't necessary, but I like to do it. I'm just going to add some dimensions to make this more even. So I'm going to make this 30 meters for that length, and then I'm just going to make this 15 so we're centered. So that's looking good. We can just get rid of this. Don't need that. Go to concept, surfaces from sketches, select your sketch, and apply. Then generate. And that looks good. Now we can do our meshing. For some reason, it puts me back to design modeler. I'm not sure why, but here we are meshing. So I'm just going to generate our base mesh, kind of what it does by itself. Obviously, we don't want this. And for this project, I'm going to be using a different method. There were 2 methods for project 2, and the one I used took way longer and just didn't work as well, and it was really inconsistent with my results. But this one seemed to work for everybody else, and I have already done this project 3, without recording it, and this method worked really well. So what we're going to do is we're going to right click mesh, we're going to insert a method, select our geometry, so the whole face, and I'm just going to make this triangles. You can just generate that. And then what I want to do is insert inflation. This is our geometry, and our boundary is going to be this edge. That looks good, and we can do 5 max layers. And that's what that does, is it adds these layers here. Okay, and then last step is we'll insert some sizing, and this will be our geometry. And I have mine, when I did this, I worked it, and I did 0.01 for my element size. That worked for me very well. Yeah, so that looks pretty good. Because we're really just looking at this area over here. So that's going to be good for what we're doing. We don't need super duper fine mesh throughout the whole thing. But that's good. We can name our edges now. So I'm just going to press N. That's the key to name. So this is our inlet. I'm going to hold control, select both of these. Symmetry. Outlets. And then that, I'm just going to name it wall. Doesn't really matter. Okay. Go back to Workbench. I'm going to update our mesh. Now we can go to Setup. We will do double precision like always. 4 solver processes. Make this go a little bit faster. All right. So same model as last project, K epsilon to equation. We're going to do enhanced wall treatment, pressure gradient effects. That's good. Go down to our material. So for my first case, I'm using density at 2 and viscosity of 400. Close that. Sorry, boundary conditions. So need to set our velocity. I'm using 20 meters per second. And this gives us a Reynolds number of 0.5. So first case is Reynolds number below 1. This works perfectly. We can go change our reference values for when we compute our drag. So we're going to go from inlet. We're going to do surface body. Our area for this is 19.635 meters squared, and then length 5 meters, our diameter. Everything should be pretty good here. Yeah, so we can go to initialize. Good. Run. We will do 500 iterations, and we can calculate that. Yeah, so it only took 24 to converge. So what we need for this project is we're gonna need our drag forces. So just like last project, force report, select our wall, print it. There we go. Then we go to Workbench, go to results. Okay, so we want velocity and pressure contours. So we'll start with velocity. Just name it. Has to be lowercase v because it'll give you an issue if you don't. So velocity, we're going to do location symmetry 1. Just do 50 contours. Okay, that looks about right. That's pretty much what it's supposed to look like. Then we can do our pressure contour. Okay, same thing, symmetry 1. We're set at pressure already. Do 50 contours. Apply that. So, see that. Now, we want our streamline pattern. That's fine. Streamline 1. What we can do is start from inlet. Probably 100 is good for this. Can't even see them, so get rid of these. But pretty much what it looks like. You have these low velocity zones around it on the front and back. And then at the very front, you have all that pressure. So, hold on. Yeah, all this pressure, low pressure zone. That's what it's supposed to look like. So that one's good. We can just close all this now. We'll close this. Yes. Now we can do case 2. So another Fluent. This is easy now though, because we can just drag this to here, drag this to here. We're going to name this B. And we can go straight to setup. And all we're going to do is change our Reynolds number. That's the easy part. So all the hard stuff is done. Now you're just changing a number or a few numbers, whatever you decide to do for your variables, and then getting your results. So that's the rest of the project. Okay, so whenever you go into a new one, you need to start straight from the beginning. So we need to set our model. You know, it's not too bad. It's pretty easy stuff. Just to do this. So I'm using the same density. I'm changing my viscosity to 5. Close that. Go to boundary conditions, inlet. Okay, new velocity at 20 again. If it lets me select it. Okay, it's weird. All right, close that. Got to change our reference values again. And there we go. Initialize. .500 iterations. Again, not going to need nearly that many. When I tested this program and tested my Reynolds numbers, only used a few iterations. So, yeah, 33. Go back to reports, get our force report really quick, just because. There we go. Now, back to Workbench, open results. Okay, so what I'm going to do is I'll do velocity, same thing as last time. 50 contours. Oh, you know what? Gotta set location to 731. There we go. So now we'll go to contours again. We'll do pressure. Set the pressure, 731, 50 contours. All right, we can look at the differences between those. Now we can do our streamline. Start from the inlet. I like doing 100. That looks good. And there's that. So that looks about right too. So checking with the sheet that we have for what they're supposed to look like, this looks right. So we are good to go on this one. We can close everything up. If you're doing this project in a later semester, I recommend that you calculate your Reynolds numbers and test them first, and then just do the project again for the video. Because that's what I did, and it makes things go smoother when you have them written out in front of you and you know exactly what you're changing. So, got C set up, change our name to C, go to setup. You get to watch me do this 3 more times. All right. So again, back to models. Viscous, K epsilon, enhanced wall treatment, pressure gradient effect. Boom. That's good. Change our materials up. I'm going to keep this at 2. I'm going to change our viscosity to 1.2. That's good. Go to boundary conditions. Go to our inlet. Right, I want 20 meters per second. Go to our reference values, change those. Go to inlet and surface body. 19.635 and 5. Okay. Initialization. Run calculation. 500 iterations, probably going to use less than 40, but why not insert 500? Yeah, so 30 exactly. Get our force report really quick. Select our wall, print it. Boom, force. All right. Get our results, make our contours and everything. All right. So, velocity. I like to start with velocity. Contours. Symmetry 1. 50. Just apply that. Do our pressure contour. Symmetry 1. 50. Yeah. And then do our streamline. 100. Start from inlet. Okay, so let's take a look at these. We already saw velocity. Let's just see pressure by itself. And then we'll see streamline. Yeah. Okay. So now close this up again. And it saves all this too. So don't worry about losing your stuff because you're going to close that. Get another Fluent. Move our geometry over. Move our mesh over. Enter setup. We will name this D. There we go. Okay. All right, almost there. Setting it up. That looks good. Okay, materials. Set this to 2 again. So I'm setting this to 0.1. Yeah, 0.1. And I originally, when I was doing this project, because for this case, it's a Reynolds number between 400 and 300,000. I had it set at like 200,000, but it looked really similar to the last case, which is Reynolds number over 300,000. And with my conditions right now that we're doing, this is 2,000. This looks way closer to what it's supposed to look like than what 200,000 did. So I'm just gonna keep it like this. I like how this one looks. That's also why it's a good idea to go over your stuff first before you take your video. So reference values. All right. Initialize this. Calculate it. That one took a little bit more, 45. Get our report really quick. Select our wall, print it. Boom. Okay. Now, get our results. All right, so contours, velocity, symmetry 1. Wrong one. A little tired. You can see the time on my computer. It's 12 in the morning, but I kind of wanted to get this done just to get it out of the way. It's not due for a couple of days though. So now we'll do pressure. We will do, yep, that's good, that's good. Location, symmetry 1. 50 contours. All right. Streamline, let's get it set up. I like 100. Start from inlet. Boom. Apply. Okay. So, yeah, that's what we want. So you can see how it kind of like goes out over it, and that's what you want when it comes off of it. How it goes kind of outward and then comes back in. That's what you want for this. And there's a turbulent pressure zone in here. If you do vectors, vectors aren't required, and I don't want to waste time in the video, but I did them in my other one. You could see like the turbulence in here. Same goes for the others. You can see the vortexes forming. So it's pretty cool if you want to check it out. Look at vectors. I was spending a little time checking those out, which I like. But yeah, so there's that one. Get rid of this. Get rid of that. I did also notice if you open 2 of the setups at once, it really messes it up. So don't do that. I think it has to do with our licensing for a student. So we'll get our last one, almost there. In the project file, it goes A, B, C, D, F, but I'm just going to go E. So drag these over. All right, setup. Almost there. Double precision, start her up. All right, still working on it. All right, so do our viscous model. Enhance wool treatment. Oh, pressure gradient effect. Don't forget that. All right, let's go to materials. What do I have for this one? Keep that at 2. Viscosity is 0.1234. Yeah, and with these values, I'm going to keep the velocity the same at 20 meters per second. With these values, we're going to have a Reynolds number of 500,000, which is greater than 300,000, and that's exactly what we need. So that works. All right. Now, reference values, almost there. Getting a little excited about being there. initialize it. Cool. Run calculation. 500 iterations. This one did take the most iterations when I did it originally. Taking way more than it did before though, so hopefully we don't have a problem. All right, cool, no problem. Took a lot more than it did when I tested this, but that's okay. Sometimes that happens. So get our force report. There we go. All right, let's go to results. See what's up. A lot of times if it doesn't converge, you'll see like in your results, it's just all messed up. You don't want that. But we should be good for this. So okay. Velocity is our variable. Symmetry 1. 50 contours. All right. Yeah, and that looks pretty right. So I don't really think we have to worry about it being messed up. All right. Do our pressure. Do symmetry 1. 50. All right, apply that. That looks right too. And streamline. Start from inlet. Boom. All right, let's start getting rid of these. So got rid of pressure, got rid of velocity. There's our streamline. And this is also how this is supposed to look. Where like with the last one, it kind of went out more. This one comes in. And you have a smaller turbulent section, which is right here. The other one had a bigger turbulent section. But this is what you want. Okay, well, thank you for watching. Until next time.